Could you explain it clearly to a 12-year-old? I see shaking heads. You are not alone. Studies done on students in the US and Poland found that 81% of people said either they know very little about GMOs or it is unlikely they know what GMOs are. Similar studies, when I do the longer version of this talk, I have more statistics from all over Europe and the US, very similar percentages. And yet, in the European Union, it is all but illegal to sell or grow GMOs. In the UK, it's only, I'm not even sure if they passed the laws to make it legal. There's a lot of opposition. In the US, it is legal. Each GMO has to be approved, but there's a lot of cultural opposition. A lot of people who say, I don't eat GMOs. And yet, some of them can't even explain what they are. Some of these people. So, there's a lot of political opposition, there's not a lot of knowledge. So what we're going to do is address the knowledge part, and then I'll come back to the political part. So I'm going to first explain what GMOs are. I'm going to then debunk 3 common myths about GMOs, and I'll give you 2 quick arguments for it, and kind of conclude on the political side. So GMO, to start with, stands for genetically modified organism. And sometimes if you get into this debate, if you start reading the literature or whatever, you'll see things referred to as GM, and then whatever the thing is, like GM tomato, and that just means genetically modified tomato. Some people prefer the term GE, which stands for gene edited. So again, you'll see like a gene edited tomato. And the reason some people prefer this is that GMO is not super, just the term doesn't make it super clear how these things are different from traditionally bred plants and animals, from things that we have domesticated over thousands of years. Because when you are breeding, for example, corn, whatever, and you take 2 individuals that have traits that you want, and you cross them, and you hope that the offspring has what you want. But it might not, because this is an imprecise method, and you're relying on natural genetics. GMOs, by contrast, there are a few different methods that are available now, but all of them involve, usually in a lab, usually using computers, to directly modify one or a few specific genes the way that you want. And this technique is based on what certain types of bacteria do out in the wild, in the world. So if you go for a walk, and after this talk, if you look at the trees, you'll see some trees that have big knobbly things on them, look kind of like tumors. In the plant world, we call those crown galls. And they're caused by agrobacterium. And agrobacterium make an enzyme that snips the DNA of the tree and inserts genetic material that instructs, if you like, the tree to make these crown galls, which the bacteria can then feed on. So a couple of scientists back in the 50s figured this out and said, we could do the same thing. Took a couple of decades, of course, to get it all sorted out and commercially available, but in the mid-90s, we had the first commercially available GM crop. So that's the basic concept. There are a lot of different ways of doing it. Like I said, there are a huge number of things that have been genetically modified. Plants, insects, animals. If you look on like the Wikipedia page for GMOs, you'll see a bunch about fish. But most of the debate centers around crops, and so that's what I'll talk about for most of the rest of the time. But just have it in the back of your mind that this is not all that it refers to. In terms of GM crops, there are 3 broad categories that are most common. Again, you get wacky things that are outside of this, but this is where most of the debate goes. There are insect-resistant crops. So the idea with these is very simple. Rather than letting bugs eat all of your crop, or what most farmers do to stop the bugs from eating the crops is to spray it with pesticide. You essentially build the pesticide into the plant so that when the plant, or when the insect chews on the plant, it dies. And this is usually done using a chemical that's based on, again, bacteria. This one is called Bacillus thuringiensis, which is a mouthful, so usually it's abbreviated to BT. BT has been used for a long time in organic agriculture, just like on top of the plants. And the only difference with the GMO is that it's built into the plant. So this has a few advantages. You don't have to buy pesticides, you don't have to spray pesticides, and then only the insects that are actually eating your plants are dying as opposed to everything, like you get with pesticides. Next one is herbicide resistant. So with herbicides, you have a sort of related problem of when you have weeds, when you have a big farm, it is not feasible to go out and pull them all like you might in your garden, right? So there is no chemical that you can spray that will kill everything but your crop. At least not yet. Maybe we'll get there, but not at the moment. You can either kill everything, or you can kill large groups of things, but that will still leave the other remaining weeds. So with herbicide-resistant GMOs, the idea is let's make the plant resistant to the spray, and then you can spray something that will kill everything, but it won't kill the crop. These are, again, if you get into the debate, you'll see things like Roundup Ready corn or Roundup Ready soybeans. This is that type of thing. Roundup is just a very common commercial herbicide. Roundup Ready crops are ones that are resistant to that herbicide. And then finally, disease resistant, and this is kind of like a subcategory that is a catch-all for a number of things. So if you didn't know, just like people, plants can get diseases. In fact, it was a plant disease that was the major cause of the Irish potato famine. So they can be very devastating, particularly when you have communities that are really reliant on one or two crops. So disease-resistant GMOs are just any GMOs that are designed, again, to be resistant to whatever disease they're dealing with. And this is often done on kind of a case-by-case basis because most plant diseases only attack one particular type of plant, so either one crop or one family of crops. So that's basically what GMOs are. But like I mentioned, there is a lot of opposition to them. They're practically illegal in the EU. You can, with a lot of work, get a few through in some places, but still several of the member states have banned it as well. So in Europe, there's a lot of opposition. But we'll see that most of the major reasons that people oppose it don't really hold up. So the first one is that GMOs are bad for your health. You see this particularly, like if you look at the US, I mentioned the sort of cultural opposition of people who don't want to eat GMOs even though they're legal in the US. And this is what people are usually, the perspective people are coming from, that they're somehow bad for you. First, taking that broadly and then specifically, so broadly, there's just no evidence for that. If you look at, when I do the longer version of this, I have like a whole slide of organizations and individuals who have declared GMOs safe based on their research or based on their studies, but just two of them for you. The European Commission, which works with the European Union, reviewed 130 studies and found no evidence of significant harm to human health. And in Italy, which has banned GMOs for decades, there was a group of, I think it was like 12 or 13 scientists who reviewed 1,783 studies, and again, found no significant evidence of harm to human health. So it's just not there. There is no evidence. Another point is you'll often hear, if people do get specific about their claims, which a lot of people don't, which should tell you something right there, but if people do get specific about their claims as to why GMOs are bad for you, they'll sometimes say that GMOs cause cancer. Everything causes cancer, right? This is the big scare, like the scaremongering thing. But in the US, GMOs have been largely adopted, particularly for livestock feed. In fact, 95% of animal feed in the US is now made with GMO ingredients, or is just GM crops. And we don't see a massive increase in cancer rates among livestock in the US. It just hasn't happened. And this has been since the mid-90s now, so it's been a couple of decades. If that were to be the effect, you would expect to be seeing it by now, but we're not. And the last sort of specific claim I've heard about harms to human health, that I kind of understand where people are coming from on this one. They'll imply or state that GMOs aren't as nutritious as their non-GM counterparts. And I can see where the thinking is on this. Like, if you change the genetics, might that change like the vitamins or whatever that are in the crops? But empirically, we're just not seeing it. The studies that were done, there was a lot of debate about this in the US in like 2015, 2016 time, and there was a lot of studies around it. And what they found was that there's some variation, but the variation is no bigger than what you get within non-GM crops. And I think this is because there are a lot of things that can affect the nutrient content of a crop besides the genetics. That's one factor, but so is the soil, so is the fertilizer you use, so is the water you use. Like, there are tons of different things that can affect the nutrient content, not just the genetics. So, it doesn't harm human health. The other big claim you'll hear is that it's bad for the environment. This is, again, a very broad claim. What do we mean by the environment? In what way is it bad for it, et cetera, et cetera? But again, these claims, when you can get them to be specific, don't really hold up. I could talk about a few more examples, but just to keep things brief, the biggest, I think the most specific claim I often hear is that GMOs are bad for biodiversity. And I don't think we should take biodiversity as like a primary value that we absolutely must go for. But even if you did, biodiversity, if you're not familiar or not 100% sure what the term means, by the way, is just the number of species in a given area. But GMOs typically actually either don't change or increase the number of species in a given area, the biodiversity. So with insect-resistant crops, I think we can see why this is. Rather than spraying a pesticide that will kill everything it touches, which will then have repercussions on the food chain, you only kill the bugs that actually eat the plants. So there are many, many species you're leaving untouched, and that again has repercussions up the food chain. And this is what we've seen when we've looked at studies of farms and areas that have largely adopted insect-resistant GMOs. With herbicide-resistant GMOs, it's really just flatline, no difference, because there you're targeting weeds. And weeds, by definition, are biologically aggressive. So even if you do manage to exclude them from your farm, or from even, say a few farms that are next to each other, you're still going to have them across the road. They are that aggressive. You're not going to cause any species to go extinct, even from a general area, just by excluding them from one farm. Just how weeds work. And disease-resistant crops aren't really going to have any effect either. So, in fact, in some cases it increases biodiversity. Other broader scale studies have found that overall GMOs reduce the use of insecticides, reduce the use of toxic herbicides, reduce carbon emissions, and improve soil quality. And if you want to understand those last two, you can ask me in the Q&A why that is. So the picture is actually looking pretty good for those who are concerned about the environment. Final claim is that GMOs are bad for small farmers, they're bad for poor farmers. And usually the basis for this claim is that often when you buy a GMO seed, you have to sign an agreement that says you're not going to save the seed, you're going to buy it again next year. So that imposes an extra cost. However, the benefits of GMOs pretty much always outweigh that extra cost. And again, we can see this in the data. So from 1996 to 2020, farmer income increased by $261.3 billion as a result of using GMOs. And before you go thinking that's all going to the rich farmers, 52% of it went to farmers in developing countries. And to put that in individual terms for specific farmers, for every dollar they invested in GM crop seed, they got a return in revenue terms of $5.22. That's a pretty good return on investment. And where that return on investment came from was 72% of that was from yield gains, which I'll talk about in a minute, and 28% was from cost savings. So if you're, makes sense. If your plants aren't falling victim to pests, if they're not being choked out by weeds, if they're not falling to diseases, etc., you're going to have more yield, and you're also not going to have to spray as much or pay people to spray, etc., and that's going to save you on costs. So very quickly, two arguments for it then from the positive side. Like I mentioned, you end up having higher yields, and this is really important not just for the individual farmers, but also for feeding a growing population, and it's also important for having more land available, because we're having a growing population who need more places to live, and we can't keep giving more land to the farmers to grow the food on, so we have to balance that, and GMOs, I think, are part of the equation. In terms of how much this is increasing, different studies come up with different numbers, but depending on crop and location, usually we're looking at anywhere between 2 and 30% increase in yields. And finally, on the nutritional front, it's not only that GMOs, again, have some variability, but overall don't have lower nutrient content. They can actually have more nutrient content, and they can be used to address very specific problems. So for example, in Asia and Africa, vitamin A deficiency is a very serious problem. You may have heard your parents when you were a kid tell you to eat your carrots so you don't go blind, right? And this is because vitamin A is good for your eyes. But if you are severely, chronically deficient in vitamin A, it can cause blindness, and it can also cause immune problems, which can lead to death. So in the 2010-2016 type period, it was nearly 2 million people a year who were dying from vitamin A deficiency and related causes, and most of those people were children under 5. So golden rice is a GMO that has been developed specifically to deal with that problem. It's called golden rice both because it's wonderful, but also because it's golden in color. And it contains vitamin A. And the idea is, in these areas where they eat a lot of rice, that's their staple crop, everybody has it, you just swap the golden rice for the traditional rice. And depending on the variety, because there are actually now a few different GMOs that are considered to be golden rice, for children, it's 1 to 3 bowls a day. For adults, it's like 2 to 5 bowls a day, and that will take care of all their vitamin A requirements. So GMOs can literally save lives. So in conclusion, although I think everybody should be free to choose whether they wish to grow the GMOs or to buy them or to eat them or whatever, there is no basis for broadly banning all GMOs, as many countries have done. And in fact, on a personal level, I would encourage people to not be afraid of GMOs and to consume them when you have the opportunity. So I can now take questions.